We've looked at how to convert a log into an exponential function and vice versa. But once we learned how to do that, we didn't really go any further than just let's take it out of log form and let's write it as an exponent. Well, now we can use that concept to actually take it one step further and evaluate the log. So for instance, looking at example A here, we have log base 2 of 16. And we can't just plug that in a calculator because the log button that you have in your calculator is programmed for base 10, which means this is a base of 2, so we can't just plug this in a calculator. So we can evaluate it. In other words, we can find out what log base 2 of 16 is actually equal to. So if they want me to evaluate, they're saying, okay, what is this equal to? So using that idea, what I'm actually going to do is, because we can work with exponentials a lot better than we can work with logs, since I'm trying to figure out what this is equal to right now, it's actually equal to a variable. It's equal to something that's unknown. So if we just use the definition of a log, that's y equals log base b of x, I'm just going to set this equal to x. And doing that, since I'm trying to figure out what this is equal to, I can now take this out of log form by moving the base over to the other side and making it the base of the exponent. And then I can actually finish solving this problem. So looking at this, we're saying, okay, to figure out what y is equal to, 2 to what power will give me 16? And of course the answer there is 4, because 2 to the 4th power is equal to 16. So log base 2 of 16 is actually equal to 4. Okay, for example B. Now this one's a little bit different. We have log base 7 of 1 over 49, but it's the same concept. Right now we don't know what this is equal to, and we can't just plug this into a calculator, so we're going to take that and just set it equal to y. Figure out what this is equal to. To do that, of course, we take the base and move it over to the other side, and to do that, that's going to become 7 to the y power equals, and all we have left over on the left side is this 1 over 49. Now this one's not as easy as the first one. The first one, it was just 2 to what power equals 16. Well, now you're saying 7 to what power is equal to a fraction. Well, if we plugged in 2 here, if we said y was equal to 2, well, 7 squared is 49, not 1 over 49. So we've got to come up with a different process to evaluating this. Now, one of the goals that we have here is if we can write the left side and the right side with the exact same base. So what I mean by that is, over here we have a base of 7. Can we take 1 over 49 and write it as the same base? And we can, because 49 is the same thing as 7 squared. So we have this equal to 7 over y, or 7 to the y power. Now from here, they're still not set equal. One is a fraction and one is not. But we do know, using the power of exponents, we can take this exponent out of the denominator, move it up to the numerator, and make the exponent negative. So make sure you review your rules of exponents, because you got to know how to manipulate an exponent. So taking it, anytime we move a base and an exponent, the base never changes, but moving it from denominator to numerator and vice versa just changes the sign of the exponent. So now it's easy to see that y is equal to negative 2. So log base 7 of 1 over 49 is equal to negative 2. Okay, example C up there. For example C, we have log base 25 of 5. Again, to start the problem out, I'm going to set this equal to y because I don't know what it's equal to, but I'm going to figure out by taking the 25, moving it over to the other side. So in other words, we're getting it into exponential form. Now again, kind of similar to example D or example B, but a little bit different, but I still have the same goal. And my goal is I want to write these big numbers, the bases, as the same number. And hopefully you can recognize that 25 can be rewritten as 5 squared. And that's my goal, is I want to get these to be the exact same base, but I still have this y on the outside. You still have this y power. So again, using our rules of exponents, we know that this is a power to a power. which means I've got 5 to the 2y power, because a power to a power tells me to multiply. So now that I have these as the same base, the base on the left is a 5, the base on the right is a 5, for these to be equal, that means the exponents have to be equal. So divide both sides by 2, and on this one, our y is equal to 1/2. Okay, so that's what log base 25 of 5 is equal to, is 1/2. Okay, and example D up here is log base 6 of the square root of 6. Now, since we're asked to evaluate this, we want to set this equal to y. We want to figure out what is y equal to. What is log base 6 square root of 6 equal to? So again, to do that, we take the base and get this out of log form and back into exponential form. Now, the other thing that we have to deal with here, which we just dealt with in a previous part of this section, is we have a radical. And everything that we do with logs and exponential functions, they either have to be in log form or they have to be in exponential form. So we need to convert this into a exponent. And using our rules of radicals, we have 6 to the 1/2 power, because it's a square root. Square root is the same thing as a 1/2 power. And now it's easy to see that y is equal to 1/2. So log base 6 of the square root of 6 is actually equal to 1/2. Alright, so I'm going to add one more to this. I'm going to add a part E, or an example E on this one. And same directions, we want to evaluate log base 12 of 1 over the square root of 12. So this is what we want to evaluate. So we're going to set it equal to, just set it equal to y, set it equal to a variable, because we want to figure out what is this equal to. Doing that allows us to take it out of log form and back into exponential form, which leaves me over here with just 1 over the square root of 12. Okay, so again, we have a radical. First thing we have to do is take that out of radical form and put it into exponential form. So we know from the previous example that to take a square root, if we have a square root, since that's 12 to the first power, this is 12 to the 1/2 power. Square root equates to a 1/2 power. And now, again, they're still not quite equal. We have to get these to be the exact same base. Well, one's a fraction and one's not, but we can take this denominator and move it up to the numerator so that they're equal, as long as you remember to change the exponent to a negative sign. So now that the bases are equal, we can see that the exponents themselves will also be equal, so your answer here is y to the negative 1/2 power.